Okay, hi viewers, welcome to this class. We're going to be looking at disproportionation reaction. Okay, disproportionation reaction is a special type of redox in which a single species is simultaneously oxidized and the same time reduced in a reaction, forming two different products with different oxidation states. Maybe one that is lower and the other one in the highest state. So we're going to be looking at equations that are often referred as disproportionation. And then I will now also, in that reaction, try to find out the species that undergoes disproportionation. Okay. As in the case of chlorine molecule, chlorine molecule um, with water. Of course, you should know that this reaction will always give chlorine water, such as this acid and this acid, two acid. Okay, the atoms here break up, and then one combines with water to form this. One combines with each atom of water to also form this. So in this reaction, the disproportionation reaction, and then we'll find out in this case oxidation number of chlorine, being that in this particular reaction chlorine atom is not combined with another species, so it's just chlorine atom. So its oxidation state is always assigned to be zero since it's a free element. Okay, in this case oxidation state of hydrogen is plus one. Okay, I will just write plus one right here because in this case it's combined with another atom. So you can see oxygen. Oxidation state of oxygen is minus two because it's combined with hydrogen. Oxidation state of hydrogen here is still plus one because combined. This one is minus. Okay, to know what this one is, find out what this one is. Because this whole oxygen here is also combined. So we have anytime oxygen is in a combined state, its oxidation state is usually minus two. So now, but the sum of these three atoms in this particular compound should have a zero oxidation state. Now, if you have plus one minus two, you still have minus one. So it means that this particular chlorine here is plus one. If we do the same thing here, oxidation state of hydrogen is plus one in the combined states, as you can see in that HCl. And then the sum of these two atoms are having a net charge of zero. So in this case, chlorine here is minus one. So now if you can now look at these numbers related to this individual atom, you will discover that oxidation state of chlorine here has changed from zero to all the way to plus one, meaning that it's oxidized in the reaction. And at the same time, the same chlorine that is zero again, coming over here, its oxidation state is minus one, meaning that it is reduced. So in a type of redox reaction like this, if a particular species, a single species, act as or behave as an oxidized and at the same time a reduced species, or when the reaction happens simultaneously like this, and one particular single species is oxidized at the same time reduced in the reaction, that reaction is said to be disproportionation. And in this reaction, chlorine undergoes disproportionation. Okay, that is it. Then there are some other also reactions that are also some other decomposition reactions that are also disproportionation, where you see a single species undergoing same kind of reaction, but this time this is not decomposition. Maybe you see a reaction whereby you have hydrogen peroxide, okay, turn into water and then oxygen. I think we always want to balance equation will look balanced first. If you look at this reaction, let's see if the reaction is disproportionation Let's see who is undergoing disproportionation, the reaction. So here we have H is plus one, always plus one in a combined state, minus my okay. In this case, oxidation state of oxygen in a peroxide. Like this is a peroxide, you can see there's an addition atom of oxygen here. Oxidation state of oxygen for one atom is minus two. So for two atoms is not minus two, but minus one. So in peroxide, just only in peroxide is where oxidation state of peroxide is minus one instead of minus two. Okay, so that is on that hand. Then on this case, this is plus one, this is minus. So since it's one atom here, so we're having minus two as usual. So this is what zero. Now in the reaction, we have nothing to say about hydrogen on this side and this side of the reaction. So, but in this case, oxygen here is minus one. So oxygen here is minus two here. So it's reduced in the reaction, and at the same time in the reaction where is from minus one to this O2, where oxidation state increase in the reaction, it oxidizes. So this reaction, just like this reaction, is a disproportionation reaction. So this reaction is a disproportionation reaction, and in the reaction, hydrogen peroxide is in the reaction undergoes disproportionation. Okay, so you can pause the video and want to look at this reaction and understand it more. Thank you.